Okay, so we are continuing with lesson 1.1. We are now on page 7, and we're looking at how you would construct a copy of a line segment. The distance along a line is undefined until a unit distance, such as 1 inch or 1 centimeter, is chosen. You can use a ruler to find the distance between 2 points on a line. The distance is the absolute value of the difference of the numbers on the ruler that correspond to the 2 points. This distance is the length of the segment determined by the points. In the figure, the length of segment RS, written RS or SR, is the distance between R and S. So we're showing that if you subtract 4 and 1 or 1 and 4 and take the absolute value of that difference, you're going to get the same answer, 3 centimeters. Here's some more academic vocabulary. Points that lie in the same plane are coplanar. Lines that lie planar, they're coplanar. Lines that lie in the same plane but do not intersect are parallel. Points that lie on the same line are collinear. The segment addition postulate is a statement about collinear points. A postulate is a statement that is accepted as true without proof. Like undefined terms, postulates are the building blocks of geometry. So postulate 1 this is segment addition postulate. Let A, B, and C be collinear points. If B is between A and C, then AB plus BC equals AC. A construction is a geometric drawing that produces an accurate representation without using numbers or measures. One type of construction uses only a compass and a straight edge. You can construct a line segment whose length is equal to that of a given segment using these tools along with the segment addition postulate. So I'm going to read this example to you guys, but just so you know, you will not be using a physical compass and straight edge, but we are learning how to do this in theory. So example 1, use a compass and a straight edge to construct a segment whose length is AB plus CD. So you are given this right here. Okay, so you have segment AB and you have segment CD. Step 1, you would use a straight edge to draw a long line segment, label an endpoint X. That's that step. Step 2, to copy segment AB, open the compass to the distance AB. So this is a picture of a compass that you would open up to distance AB. Step 3, place the compass point on X, right here, and draw an arc. So if you put this compass here and you were to draw the arc, it would give you that exact length. And you're going to label the point Y where the arc and the segment intersect. Step 4, to copy segment CD, open the compass to distance CD. So you're going to use your compass again, but it's going to be a much longer segment, okay, because it's trying to match the one up here, CD. And then place the compass on point Y and draw an arc, okay, and label that point Z. This is where the second arc and the segment intersect. So from all of that, what you get is XZ, and that's the required segment. So that's how you can use a compass and a straight edge in theory to construct a segment whose length is AB plus CD. We're going to come over to page 8, but we're going to skip all the way down to explain to, okay? So we're moving on to using the distance formula on the coordinate plane. And we're going to talk about the Pythagorean theorem. So that should be familiar to you guys from last year and from 8th grade. The Pythagorean theorem states a squared plus b squared equals c squared, where a and b are lengths of the legs of a right triangle, and c is the length of the hypotenuse. You can use the distance formula to apply the Pythagorean theorem to find the distance between points on the coordinate plane. And we're going to look at how we do that. So I'm going to move on to page 9. Okay, and so this is the distance formula. This is definitely something you're going to want to add to your notes. Okay, the distance between 2 points, x1, y1, and x2, y2 on the coordinate plane is the square root of x2 minus x1 squared plus y2 minus y1 squared. This comes straight from the Pythagorean theorem. So if you have a right triangle like you do in this image over here, typically you would have side lengths A and B, and this would be C. Okay, the distance we're talking about is C. It's this distance right here between the 2 points. So instead of doing a squared plus b squared, we're using the distance from x2 to x1. Oh, sorry. Okay, so we're just rewriting it. And now we're going to be able to use that. So let's look at example 2, determine whether the given segments have the same length. You have to justify your answer. So, I mean, you could look at that and say like, yeah, I think it's close. But, in mathematics, that's not justifying your answer. We're going to have to do some proving that it is actually true. So the first part for A here, it says, use the highlighter instead so you can still see it. For A, AB and CD, right? So AB is this segment here, and then CD is this one here. These are the two that we're trying to see if they have the same length. So a method of doing this is to write down the coordinates of the endpoints, and that's what they did. So for A and B and C and D, they wrote down all those coordinates. And then to find the length of AB, okay, that means we're looking at the x values. So let me use a different color highlighter actually to show you. Okay, so if we're subtracting our x values from A and B, that's why here we have 1 minus -4. And we're going to subtract our y values, which are 4 and 2, 2 minus 4. We're always subtracting them, okay? And as long as you're consistent with how you choose to order them, it can go either way. And as you simplify this, it comes out to be the square root of 29, okay? And now we're going to move on, and we are going to find the length of CD. So we're going to look at our x coordinates, which are 2 and 4, and that's why we're subtracting them here. And then we're going to look at our y coordinates, which are 3 and -2, and that's why we're subtracting them here. Once you simplify this down, it comes all the way out to square root of 29. And notice we're leaving it as the square root of 29. We're not going to approximate that into something else. The square root of 29 is an irrational number. So by leaving it as the square root of 29 is an exact answer. And so we can conclude mathematically that AB is equal to CD, which is equal to the square root of 29. That is, segment AB and segment CD have the same length. All right, we're going to do another example. This time we're going to look at segment EF, and we're going to look at segment GH. Okay, and it's asking you to fill in from the picture above. All right, so they give us E, but we don't have F. So we're going to come back to our picture and look at F and find our coordinates. This is point F right here. Okay, and F has coordinates, looks like -2 and -3. So that's what I'm going to write in these boxes. I'm going to put -2 and -3. And then for H, which is right here, we have X coordinate of 2 and a Y coordinate of 0. So this is going to be 2, this is going to be 0. And now it's just a matter of plugging in the pieces in the right order. Okay, we're going to subtract the X values. Let's see, let's be consistent with my colors. So I'm using green for X's, X and X. And the green for those two when we get to it. And then I'm using, I think, orange, right? Yeah. I'm using orange for my Y's. You know, it does help to highlight, helps to kind of help you, saying help a lot. It helps you to organize all these different things. Color coding will definitely benefit you. All right, so I'm going to write with green to match the highlighter color. And so for EF, okay, so I need to subtract my x's. They already have -3 here, which means I'm going to need to put -2. I'm going to need to write -2 there. And I'm actually just going to use black because I don't have an orange pen and I don't think it'll look very good. Okay, and then to subtract my y values, we've already chosen the order. Okay, so we're using the f value and then the e value. So the f value is going to go first, which is -3. So I'm realizing if I touch my screen and I try to write at the same time, it's taking it as a zoom in, zoom out type of operation. Okay, so we're going to simplify this. -2 minus -3. And maybe you remember the little saying, drop a line, change the sign. Okay, so we can actually add these two values together. -2 plus +3 is going to give me +1. And for -3 minus 2, that's going to be -5. If I square 1, I get 1. If I square -5, I get 25. So I get the square root of 26. And we'll leave it just like that. 26 is not a perfect square. We do not get a nice rational number if we try to take the square root. So we're going to leave it as the square root of 26. And now we're going to look at GH. So X values you subtract first. -2 is already chosen to be in this spot right here. So that leaves me to put a 2 here. And looking at our Y values, that means I have to put a 0 here. Simplifying this, again, when you have a minus and negative, you can think of drop a line, change the sign. So 2 plus +2 is 4. And over here, 0 minus -4. Again, you can think of drop a line, change the sign. 0 plus +4 is 4. 4 squared plus 4 squared. Order of operations. You square before you add. So 16 plus 16 is 32. All right. So now we got to take this math and make some sense of it. It says that the length of EF was the square root of 26, and the length of GH is the square root of 32. Those are not the same number. So since EF does not equal GH, therefore EF, segment EF, and segment GH do not have the same length. Okay, EF and GH do not have the same length. So we are now going to move on to page 10. We are not going to do number 7, but on page 10 we are going to look at number 8. It says determine whether JK and LM have the same length. Justify your answer. So we are basically doing what we just did, except we don't have the neat little spots to plug in for us. So let's start by identifying the coordinates of the points that we have. We need the coordinates for J, we need the coordinates for K, and the coordinates for L, and the coordinates for M. So J, our coordinates for J are -4, 4. Our coordinates for K are -2, 1. Our coordinates for L are -1, -4. And our coordinates for M are 2 and -2. Okay, so J is here, K is here, L is here, and M is here. So we want to figure out if these two segments, JK and LM, have the same length. And we have to show this mathematically. We can't just look at it and say, yeah, they're about the same. So it works. No, we got to prove it. All right, and we're going to use the distance formula to do that. So let's first look at JK. JK, sorry. Okay, so JK is the square root. It's a giant square root symbol here. And we want to subtract our x values and square them. And then to that, we will add the difference of our y values and square them. Helps if you set it up like that first and then go back and plug in your values. So J and K, I need those x values first. Let me grab my highlighter. I want to show you this step by step. If it's too much information, you can just fast forward, and if you totally get it, that's fine. But, I want to make sure I explain it to you guys as much as I can. That's my job. All right. So we're going to put -2 and -4 in here. If you have a negative next to negative, you can add some parentheses for cleaning up your notation. And then we're going to look at our y's. 4 and 1. So I have to make sure I write this in the same order, which means 1 goes first, 4 goes second. Okay, so JK equals the square root of, we got to simplify this all down. All right, well, -2 minus -4, drop a line, change the sign. That's -2 plus +4, which is 2, right? So in here I have 2 squared. And then to that, I am adding 1 minus 4. That's -3. -3 squared is 9. Okay, so this is really just 4 plus 9. The square root of 4 plus 9 is the square root of 13. Okay, so I know that the length of JK is the square root of 13. This is the distance formula. Essentially, I'm using the Pythagorean theorem to find that distance. Okay. Now we're going to look at length LM. So again, a big square root symbol. We're going to be subtracting some x values here and squaring them, and then adding the difference of some y values here that are squared. Okay, helps to write that down first. And now I got to figure out what do I put where. So let's go ahead and highlight our x values. We have -1 and 2. And I'm going to plug those into my formula, distance formula. So I'm going to put the 2 there and the -1 there. I could flip it around and do it the other way. I just have to make sure whatever I choose to do for the x's, I do the same order for the y's. And then we're going to look at our y's. We have -4 and we have -2. So the same order means I'm going to write -2 first and then -4. And I got to simplify this. Well, a negative and a negative. And I kind of forgot to throw in my parentheses here for good notation. Drop a line, change the sign, adding the opposite. All right, so let's clean this up a little bit. LM equals the square root of 2 plus positive 1. That's 3. 3 squared. All right, plus negative 2 plus positive 4. That is 2. And it's 2 squared. So question is, what is 3 squared plus 2 squared? It's the square root of 9 plus 4. And look at that. It's the square root of 13. I got the same thing. All that work. So what did I even just prove? Square root 13, square root of 13. The length of JK is equal to the length of LM. I just determined that they do have the same length, and I've proven it with mathematics. Awesome. Okay, so we're going to just read through. Actually, let's stop this video here, and I'll make one more video to go on with finding a midpoint.